Hello, welcome back. So in the previous part, we have seen various types of building structures. Now in this part, we will see there are some common characteristics that all structures have. And first of all, I will take an example of a very simple structure like this. So in this structure, you can see there is a combination, like there are different elements like the slab. This one is the slab, and this horizontal element, this is called the beam, and vertical elements, these are column, and columns are resting on the foundation. Now column has their foundation, so they are resting on the foundation, and foundation further rest on the ground or on the soil. So now with this diagram, now we will see what are the common characteristics of the structure. Now, the most common characteristic of the structure is that all the structures are designed to support various kinds of load. So all the structures that we design, they are designed to support different types of load. Now, the load that structure supports, those loads are known as structural loads. And these structural loads are further broadly classified into three categories, and these three categories are these structural loads can be dead load, they can be live load, they can be environmental load. Now this dead load is the category of gravity load. Now we know that our earth is circular, and uh, the gravity, or our earth is having a gravity, and this gravity is such that all the things that is present on the surface of the earth, this gravity attracts towards the center of the earth. So for example, if there is a body on this earth, then this body is attracted towards the center of the earth. So whatever, wherever any body is there, it will be attracted towards the center. So that is the gravity load. And if we look our on the earth locally like this, so the load of this body, or the self weight of this body, will be attracted towards the gravity. And if we look at this as locally, then we will consider this load as vertical load. So in this case, you can see this building, the self weight of the building, it is acting as a gravity load, and it is the vertical direction. Okay. So dead load will consist of self weight of building, or maybe some other superimposed load that will be coming on the building. So dead load, as the name suggests, dead load is the permanent load which will not move anywhere. Similarly, the another category of load is the live load. Now this live load is actually the moving load, and this live load is not certain at any particular time. So so generally we design our building to resist some load. For example, if we are designing a bridge, so on that we are designing that bridge for the traffic movement. Now in that case, the load of the traffic will be live, and we are actually designing our building to resist that live load. So live load is basically a moving load. It is not stationary, and also it is not certain. So similarly, like if we take an example of residential building, so all the occupants, all the people, those all those people which live in the building, the load of those people will be as a live load. Similarly, the third category of the structural load is the environmental load. Now there are various types of load which comes under this category. Now environmental load can be wind load. So this wind load effect on our building is very much significant when the height of building is very large. So on the large building, the effect of wind load is significant, and in that case we consider this wind load, effect of wind load. Similarly, other environmental load can be earthquake load. So because of the earthquake, our building will shake. So generally we design our building to resist earthquake impact also. Similarly, other environmental load can be temperature load. Now we know that all the materials, when temperature is high, they expand, and uh, when the temperature is low, they try to contract. So for example, if we take an example, like there is a body, this vertical body, and similarly this there is another vertical body, and if these two bodies are connected with a horizontal member, so what happens is when the temperature will be high, this horizontal member will try to expand. In that case, this body will like will be like this, because this is trying to expand, so it will uh, force on this body to move away. Similarly, when there is a low temperature, this body will try to contract, and in that case it will try to get along uh, like in this direction. So the temperature effect is again considered under the category of environmental load. Similarly, there may be uh, the load of snow load. Like if we construct our building in the hilly area, like in the where the snowfall occurs. So snowfall may rest on the building, and it will also have some load. So when we design our building in the hilly area where snowfall may occur, in that case, we design our building so that it can resist the load of snowfall also. So these loads comes under the category of environmental load. So basically our structure is designed to resist all these three broad category of the load, like the dead load and live load and the environmental load. Now, another characteristic of the structure is that all the structural load in the structure, it is being transferred from building to the ground. So that is also the characteristic which all buildings follows, like load is coming from the external factors, and that load is transferred to the soil. So this building, it actually acting as a bridge for the load. So load is coming from top. Now this load is being transferred, like if we take the example of this building. In this building, the topmost element is the slab. So load will be coming on the slab. Then slab is resting on the horizontal member, which are beams. So slab will transfer its load on the beam, and these are the beams. Now these beams are connected with the vertical members. So these beam will transfer the same load along with its own self weight. It will transfer the load to the vertical member, which is the column. Now column will also take this load to the, I mean, it will transfer this load to the foundation, and this foundation is resting on the soil or on the ground. So this foundation will further transfer the same load on the soil, on the ground. So we can say that all the structures that we construct, they are actually acting as a bridge for passing the load. So that is the common characteristic that all building structures is having. Now, when while transferring the load at all the support points of the structural members, these structural members generate reactions. Like for example, like the slab is transferring the load on the beam, and beam further resting on the column vertical members. So the point where it is being connected, so at this point, when the beam is transferring the load to the column will offer a reaction. Like beam is having vertical load, and this vertical load is transferred to this vertical column. So this column will offer the reaction on the connecting point where this beam is connected. So at all points, similarly, this column is connected with the foundation. Now, as the column is transferring the load to the foundation, foundation will also offer the reaction, like this one. Similarly, the load is transferred on the foundation, and foundation is resting on the soil. So soil will also offer the reaction. Like you can see these small arrow, they are actually showing the reaction offered by the soil. So that is the thing that happens when the load is transferred to from one element to the another element. Now it says external load and the reaction that resist these loads produce different kinds of stresses. Like as I said, that when the beam is transferring the load to the column. Now column is made up of any particular material. So small particles in the column, they will offer the resistance. They will try to oppose that, which means they will offer the reaction. So that reaction offered by all the elements, if we consider that a unit element, so that reaction is actually the stress. So force per unit area, generally we call this as the stress. So we will discuss more about these stresses in detail in the later lectures. So this stress is actually the force offered by a unit particle or unit area. So now we will discuss our another topic, which is the fundamental principle of the structural analysis. So that is also very much required. Now you can see slowly we are going to our main content of the syllabus. So now we will discuss this. So what are the fundamental principles on which our analysis is based? Then in that case, I would say that the fundamental principle which are used in the structural analysis is based on the Newton's laws of inertia and motion. And all three laws I will be showing you here. So those three laws are applicable in all type of analysis that we will do. So we know that this is the first law, and in the first law it says a body will exist in a state of rest or in the state of uniform motion in a straight line unless it is forced to change that state by forces imposed on it. This is also called law of inertia. Second law is the rate of change of momentum of a body is equal to the net applied force. So if there is a body, if we apply a force, then this body will get into the motion or in the momentum. So the rate at which this body will have motion, so that rate is equal to the force that is being applied on it. So that is the second law of the Newton, and this second law will actually give the definition of the force. Now third law is for every action there is an equal and opposite reaction. I was just discussing about it in the previous slide, that all the load which is being transferred from one element to the another, but on the connecting point they offer the reaction also. Like if this beam is connected on this vertical member, then this beam will have some load. Now this load is opposed by the column, like the column will offer the reaction. Okay, so this law is applicable, this third law is applicable here. So now as we know that these are the laws of motions, and they can be expressed by a equation which is summation of all the forces acting on a system. It is equals to the mass into acceleration. M is mass and A is the acceleration. But now we have to see that as we are focused on our building structures only, so we know that this acceleration will not occur in our building, or motion will not occur in our building. Our building is stationary, and therefore our building, I mean all the forces that are acting on our building, their summation will be zero. So for example, if this is the building and if it is standing on the ground, so the load of the building, which is say downward load, or maybe because of the wind it may be horizontal load, or because of earthquake, again it may be the horizontal load. So all these loads will be balanced by the reaction offered by the ground. So you can see there are various forces acting in this system, and all the forces, their summation will be equals to zero. So this equation will be modified as summation of force will be equals to 0. Now this is the condition of equilibrium, which means our body, our building structure will be under the equilibrium, which means all the forces acting on our building, their summation will be 0. And that is why they are standing like that. If it is not 0, our building will collapse. So this is a very special condition, and now we will be dealing with this condition, and we will follow this equation, which is summation of F is equals to 0, which means summation of all the forces is equals to 0. So as I have written here, F is the summation of all the forces, and M is the mass, and A is the acceleration. So as I said, in this course, we will be dealing with a very particular type of equilibrium, which is called the static equilibrium. Static means stationary, in which the system is not accelerating. Now, system is referred as a building, in which building is not accelerating. So all the force which are acting on our building, they are not actually accelerating our building. If it is accelerating, then our building will collapse. Okay. Similarly, this equation is called the equation that I have shown like this, summation of F is equals to 0. This is the equation of equilibrium. And therefore, the same I have shown here. So we will be following this equation, which is the static equilibrium. Well, basically, as we know that this is the equation of force. Now here force is, we are actually considering this force in two categories. One is the static force, and another force is the dynamic force. Now static force is when all the forces are stationary, okay, and summation of all the forces is 0. Now dynamic force is actually the time dependent force, and the magnitude of this force is not certain. At a particular time it may be 0, at a point of time it may be in some magnitude. For example, the earthquake. So earthquake magnitude is not certain anytime. Like in our building, at one point of time there is no force, and when earthquake comes, then there is a force of earthquake in the building. So earthquake force is considered as dynamic force. So we will not be dealing with this dynamic force, we will be dealing with the static force only. And static force condition is this one, in which summation of all the forces will be 0. So now in our course we will be talking about static force only. Now in this condition, static force, like you can see, these structures either are not moving, as in the case of most building, or are moving with a constant velocity, such as the space vehicle, which means like our building, it is not moving, it is in the stationary position. Then this equation will be applicable, and this equation will be applicable in case when the body is in the continuous motion or constant velocity, like in case of the space vehicle. All the satellites which are moving in the space, they are moving with a constant speed, constant velocity. So in that case also we can apply this equation. So we will continue our this discussion in the next part. Thank you.